Hey, some people noticed a problem with this sign. More specifically, it's this sign with guidelines on social distancing. It's being used by the San Francisco Public Works Department. You can see here one of their employees putting it up across the street from the Tanner family house. At first glance, it looks fine. It says clearly to maintain a distance of 6 feet. But if you look closer, you'll notice that the arrows indicate that the 6 feet of distance is the diagonal distance of the square. And if the diagonal distance across the square is 6 feet, then the length along each edge must be less than 6 feet. We can prove this physically with a little bit of geometry. We know that every rectangle can be made up of two identical right triangles put together, and also that every square is just a special kind of rectangle where all the edges are the same length. So to start, we draw a line that is 6 inches long. You could do this drawing a line that's 6 feet long, but my whiteboard isn't that big. And then draw 2 more lines, starting from the end of that first line, meeting together at a 90-degree angle. These 2 lines should be the same length. Now you just measure those 2 lines, and we see that they're both about 4 1/4 or 4 1/2 inches long, which means that when we scale it up to full size, that square will have edges that are a full 1.5 feet less than a minimum recommended 6 feet. We can also prove this mathematically. We'll start by drawing another square, and this time it doesn't matter what the scale is. And by drawing a line from one corner to another, you can see that we now have 2 identical triangles. We're going to erase the first one, just so that it's a little bit easier to see. And so we're left with a single right triangle, with 2 short sides, A and B, and a long side, or hypotenuse, of C. Now the Pythagorean theorem states that a squared plus b squared equals c squared. We know that c is equal to 6, and we also know that a is equal to b. So we can start making some substitutions. A squared plus b squared equals 6 squared, which is 36. And a squared plus b squared can also be written as a squared plus a squared, which is also equal to 2 times a squared. We cancel out the 2 on that side by dividing 36 by 2. Now we have a squared equals 18, which means that a is equal to the square root of 18, which is 4.24. There's actually a shortcut we can use that takes advantage of the fact that a and b are the same. If c squared is equal to 2 times a squared, we can actually take the square root of those individual elements and see that c is equal to the square root of 2 times a. So to find the value of a, we just need to divide c by the square root of 2. And 6 divided by the square root of 2 is, again, 4.24. Okay, so that's why the sign doesn't work. What's our fix? Well, the easiest thing to do is just move the arrows. I started by moving these icons for the little people farther apart so that we'd have more space to work with. Then I added in the arrows in between them, indicating that we were looking at the length along each edge. Lastly, I put 6 feet in between them, and there you have it. Incidentally, there are plenty of signs that are already using this layout, such as this one, which is being used in Oregon State. Of course, the way they have their stick figures and the shopping carts arranged makes it look like either everybody is lying on their side and we're looking at them from above, or that we're looking at them from the side and those 2 on top are just sort of floating in midair, 6 feet above everybody else. And I've yet to see anyone take social distancing that far. Of course, this does leave us with the question of what is the diagonal length along this new square? Well, we can actually use a very similar process to answer that question. Again, starting with a square that has edges of 6 feet in length, we can create a new right triangle with an unknown hypotenuse of x. I'm just using x instead of c because we already solved for c once and I don't want to get confused. Using the Pythagorean theorem, we see that x squared should be equal to 6 squared plus 6 squared, which is 36 plus 36, which is 72. That means that x is equal to the square root of 72, which is 8.485 feet. For simplicity's sake, I'm going to round 8.485 to 8.5, and since 0.5 feet is half a foot, we now know that x is equal to 8 feet and 6 inches. Of course, if you're using the metric system, then the minimum recommended safe distance is 2 meters. And we can use a similar shortcut as we did before, except this time we're going to multiply 2 meters by the square root of 2, which gives us 2.82 meters. So there you have it. The distance along the diagonal of a 2-meter square is 2 meters and 82 centimeters. Well, now we can go back to our sign and plug in the new information we've calculated, so that we've got a nice big square with 6 feet along each edge and 8 feet and 6 inches across the diagonals. There, I fixed it. Although honestly, having that much information in one image makes it a bit too busy, so I'd say stick with a square of 6 feet along each edge. That should be easy enough to follow. Well, that's all I have for you right now. If there's anything else needs fixing, you let me know. And as a little addendum, I wanted to go over some of my penmanship. You may have noticed that when I wrote my X, I gave it a jaunty little hitch on this one arm. I started writing them that way in high school as a way to differentiate the letter X from the multiplication sign. This is also why I started writing my lowercase t's with a bit of a loop so that I wouldn't confuse them with addition signs. Eventually, I even started drawing my lowercase l's with a bit of a loop so that I wouldn't confuse them with ones or with absolute value brackets. Incidentally, I draw my ones with a bit of a hitch at the top, but I don't often add one at the bottom, although sometimes I do. These are just a few of the ways that taking a lot of math and science courses affected my penmanship over the years, but yeah, it's a little look into my brain.